Hi, this is Mr. Hodgen. I am going to do the review for our first quiz this year. Let's go ahead and get started. Alright, first part of the review is all about solving equations, mostly two steps, including fractions. So just in general, remember we're trying to get the variable by itself, okay, which is x or a or y, whatever variable is there. And we generally want to start on the side of the variable by moving or canceling out all the other constants and coefficients. Remember, a constant is any number that's by itself, and a coefficient is any number in front of the variable. Generally, we add, subtract constants first. Like on this, we would add 12 to both sides to cancel it out. Okay. And see how this is 0. We're left with 4x equals negative 80. And the second step is generally to divide by the coefficient, or if it's a fraction, to multiply by its reciprocal. Okay. So we can divide by 4 on both sides, or multiply by 1/4 on both sides. It means the same thing. In either case, our goal here is to get a 1. So 4 divided by 4 is 1. So we have 1x equals negative 20. And there is a way to check your answers. All of these, I'll do it on this one only, but you can do them on every equation just to make sure your answer is correct. So theoretically, all of these on your quiz, you should check and know if they're right or wrong before you turn in your quiz, because you have already gone through these steps and seen that they work or they don't work. Remember, if when you plug it in, we're really saying, well, is this equal? Is this really equal or not? And then as we can see here, yes, you get the same thing on both sides. So that means our answer is correct. Checks out. There we go. If I got a different answer on each side, then I know my solution would be wrong. Okay. So you want to do this for as many problems as you can that you have time for. Alright, so let's go through the rest of these. Again, I'm going to start on the side of the variable, add, subtract the constant. In this case, it's negative 32, so to cancel it out, add 32 to both sides. Okay, that's 0. 2x equals, so it'll be 56. Now this is a common mistake. What's wrong with what I just did? Okay. So we'll be very careful. You see this is a subtraction sign, so it becomes a negative sign. Just because there's nothing in front of it, because we canceled out, still have to bring it down. So be very careful there. Alright, so now we can multiply by negative 1/2 or divide by negative 2, same thing. Alright. So x equals, what would that be? 28. Again, very common mistake of what I just did. You say, okay, 56 divided by 2 is 28, and then end up forgetting the negatives. So please remember those negatives. Very easy to forget. After you finish everything, go back and check all those negatives. Alright, there we go. So we have similar, but we're going to start with some fractions. Now, if you prefer, you could work with this. You can always remember that this is a 1m, m by itself, there's one of it. But if some people like to have the variables and the coefficients separate. So if you prefer, you can solve this equation, and it is the same thing. So 1 minus half of what number is 4? 1 minus half of some number. 1/2 of a 10, or 1/2 of negative something. Yeah. So we can start by, again, same rules. Side of the variable, we start with the constant, the number by itself. So we have 3 is, okay, again, I'm just making that common mistake again on purpose because we see it so often. Bring down the minus. Okay, good. Alright, now we don't want to divide. Before up here we would, any number in front of x, the coefficient, we just divide by it on both sides. But in this case, we don't want to divide by a half. We're going to multiply by the reciprocal. Multiply by the reciprocal. Okay. The reciprocal does two things. It cancels both the 2 out, because this really means multiply by -1, so let's divide by -1, meaning put it on the bottom. And down here, having the 2 on the bottom means to divide by 2, so we multiply by 2. So in effect, we're just trying to cancel out, so these both become +1. Of course, we want to do it on both sides. So we have m left over on the right-hand side. Everything else equals 1. And on the right-hand side, 2 times 3 is 6, but divided by -1, that is -6. So again, you can check these, do the whole check, or you can mentally check them if you don't have time to write it out. Just think, well, see, half of -6 is, -6 divided by 2 would be -3. 1 minus -3 is 4. So yeah, it checks out. I didn't even have to write it down. I know it's correct. Okay. Again, we can continue this. Same idea, just variable on the other side. Start with a constant. That's the number by itself on the side of the variable. So we'll do the opposite. Get it to be 0. All right, that's 0. Again, if you prefer, I like to put the variable down in front. Equals 4 plus 2, which is 6. Alright, now we need to not divide by 3 over 2, but multiply by its reciprocal. So 2 over 3, so that 2's cancel out to be +1, the 3's cancel out to be +1. Both sides. So we have n equals 6 times 2 is 12. 12 divided by 3 is 4. Let's keep going. Same rules. Now fractions do not change any of the algebraic rules. We still start on the side with the variable. The number in front of the variable is still the coefficient. The other number is still the constant. So we still start here. Okay. So just pretend that it was not over 4. You know you subtract 3 on both sides. So we're going to do that here. We're going to subtract 3 over 4 on both sides. There we go. So we have -9 minus 3, which is -12, and -12 over 4 is -3. Okay, we can go ahead and finish. Divide by the coefficient both sides. So we have -1 is equal to x. Everything cancels out. Constants, add, subtract, always add to 0. Coefficients, when we divide, should be equal to 1. There we go. And let's go to number 6. That's to the right. There we go. Right, same rules. Start on the side of the variable. So we have some number is being divided by 2 over 2, and then subtracted is 3/4. So we just do that in reverse and do the opposites. We're going to get rid of the subtracted 3/4 by adding 3/4. Okay, so we have some number divided by 2 is equal to, let's see, a fourth plus 3/4. That's 4/4, which is 1. And then from here, well, you can already, if you read this equation, as what number divided by 2 equals 1, you could probably know the answer is 2. 2 divided by 2 is 1. So let's prove it. A little bit of algebra. There we go. So multiply by 2 on both sides, and there you go, 2. So you can plug it back in. 2 over 2, that's 1. 1 minus 3/4 is 1/4. A few more examples. All right, side of the variable. Now the coefficient here is -1, right? So it's still a coefficient. We'll do that last. But first we got to take care of positive 7/12. So subtract 7/12 on both sides. Minus 7/12 on both sides. Okay. Bring down this -1n. Don't forget the negative. Okay, 5/4 minus 7/12. Let's do a sidebar here. Okay, so common denominator will be 12, looks like. Both 4 and 12 go into 12. The second here does not change. It's already a 12. But here we have to multiply by 3 in order to get 12. 15 over 12 is equivalent to 5 over 4 by multiplying by 3 over 3. And 15 minus 8. 7 is 8. 12. And without being told, remember, always reduce fractions. So 8/12 if we divide top and bottom by 4 is 2/3. 2/3. Okay. And let's finish it off by dividing both sides by -1. Or actually, let's do it the other way. Whenever you have a coefficient of -1, you can divide or multiply by a -1. So I'm going to multiply by -1 here. Just because it looks weird to say 2/3 divided by -1. Okay, so -1 times -1 is +1. So we have 1n equals -2/3. There we go. A few more. Obviously, we put a lot of fractions in here on purpose, so you guys get practice doing your 5th and 6th grade arithmetic. So we're going to be using a lot of fractions all year, so we need to be good at fractions. Okay, still starting on the side of the variable. Okay, working with the constant first to make it 0. We'll add 5/3. I'll write it to the side of it this time. Add 5/3. Okay. This is 0. 2x equals. Now notice how I'm keeping my algebra and arithmetic separate. So when I need to find out what 1/2 plus 5/3 is, I'm not going to do the work right here and get in the middle of solving my equation. I'm going to take it to the side, do the arithmetic, which arithmetic involves only numbers, figure out what the answer is, and then bring it back and put it back in the equation. This keeps your work clean and organized. Okay, so our common denominator is 6, since both 2 and 3 go into 6. And so we had to multiply by 3 on this side to get 6. So we got 3 times 1. And on this side we have to multiply by 2. Right, 3 times 2 is 6, so 5 times 2 is 10. And we have 13/6. So I found out what this equals, and I bring this answer back in here. Now you can see, if I divide both sides by 2, look what happens. It looks kind of confusing, right? Because we got a fraction, but then we have another fraction. So anytime a fraction is involved on either side, instead of dividing by 2, let's multiply by the reciprocal. So make it 2 over 1, right? And then we can multiply by 1 over 2. And this is far more familiar right here. Okay. So we have 1x equals 13 times 1 and 6 times 2, 12. And this is acceptable as your final answer, a reduced improper fraction. If you prefer, you can change this to a mixed number. In that case, 12 goes into 13 one time with a remainder of 1 left over. And that's okay as well. And if this was a word problem, we'd have to possibly do more work. Like if this question was asking how far was it away or how long did it take, we wouldn't say it was 13/12 miles away or it took us 13/12 hours. We would probably convert it to a decimal so it made sense. But for just practice problems without any context of a word problem or a scenario, a reduced improper fraction is fine. Okay. Just a few more. And more practice with fractions. Remember, we do not want to say, I got this equation wrong because of fractions. Fractions are from elementary school. Years and years ago, we may not be great at them, we might be a little rusty, but everybody in high school can definitely do these. This takes a lot of good practice. Alright, again, I'm going to go off to the side and calculate this. I'm not going to get in the middle of my equation. So I have 5/12. Okay. I need a common denominator of 12, so multiplied by 3. And now we have 8/12, which again divide top and bottom by 4. So 8 divided by 4 is 2, 12 divided by 4 is 3, and we have 2/3. Okay, good. Now, this is pretty clear what the answer is if you're not stuck just thinking about steps. So what over 3 equals 2 over 3? Okay, hopefully 2 comes to mind. 2 over 3 is equal to 2 over 3. So y must be 2. So you can think this as you're going through problems. If this comes up, oh yeah, that makes sense. 2 over 3 equals 2 over 3. So when you solve it and show the algebra, you should already have an idea of what the answer is. And since this is y divided by 3, I'm multiplying by 3 on both sides. Okay? And voila, y equals 2, just as we thought. Alright, right side's a variable, and it's a negative m, which is the same as negative 1 m. So I'm going to start with a constant, though, the number next to the variable. Here we go. So it's 1/2. So it's positive. I'm going to subtract a half. Subtract a half. I'm going to bring down negative 1m. Do the work for this off to the side, so it doesn't interfere with the equation. 5/6 minus a half. Common denominator of 6. 5/6 minus 3/6 equals 2/6, which is 1/3. Right, bring it back here. 1/3. So we can, since we have a fraction here, I'm going to go ahead and not divide by negative 1, but I'm going to multiply by negative 1. Either one's correct, but this just seems a little bit cleaner. So negative times a negative is positive, just 1m, that's what we're looking for. And negative 1 times 1/3 is negative 1/3. There we go. Alright, so that completes the front side. Let's go to page 2. So routine problems are done. You can see a majority of the quiz, it looks like word problems, so we're going to have to know how to translate scenarios into equations. So we broke it up. This is how we're going to come up with all our equations and answers for word problems. First we have to figure out what it is that we are finding. What it is that we don't know. That's what the variable is. That's what we're trying to figure out. The thing we don't know. So instead of equation saying, well, this is what we don't, this is the thing we don't know, we just call it some letter. And that's called a variable. So define a variable. A good way to figure out what it is you're looking for is look where the question mark is. That's what we're trying to figure out, right? So look at the sentence. How much is a monthly gym membership? So you can give it any variable that you want, any letter. I like to make it kind of related. So since we're trying to find the monthly gym membership, I'm going to say M is going to be our, instead of writing or thinking monthly gym membership, we can just say M. Monthly gym membership. Right, now we can write an equation. So it says that the gym membership requires first monthly membership dues paid in advance plus 2.5 times the monthly payment for a personal trainer. The total payment for Robert Page was $140. Alright, and again, how much is a monthly gym membership? So once we finish solving the equation, we'll have M left over, and that will be our answer to what we're looking for. Now this one we're not actually going to solve, but we could go ahead and do that. So the monthly gym membership, okay, first monthly membership, and that's exactly what M is. It's a monthly membership. So it also says he's getting 2.5 times, that's the key right there, times, multiply, the monthly payment. Now realize that times the monthly payment, that's the same thing as here. Monthly gym membership, monthly payment, that's the same value. This is M. Right? So they might say the same thing in a different way. Here they're asking what's the monthly gym membership. Here it says what's the monthly payment. Those are the exact same thing. So 2.5 times M. 2.5 M. And we know this all adds up to $140. Alright. And it's not normal to put the dollar sign in here. You don't have to do that, but definitely if we did solve this and got an answer, you would definitely want to put the units at the end. Okay. Now the rest of these are very similar. We're going to see a little bit of okay, I'll take a break for a second. Here we go. So the rest of these we're going to work out now. You might see some similarities between some of the problems. So if you kind of seem like you're doing repeated steps, that's what the review is for. Lots of practice. Okay, so Mrs. Bengal can hike 3 miles in 45 minutes. If she continues at this rate, how many minutes will it take her to hike 5 miles? Okay. Now you can see this is hopefully by reading this is a proportion setup. Okay, so proportions we want to write down what it is that you're going to put on the top and the bottom. Now no, there's many different ways to set up a proportion. There's actually 4 correct ways to set up a proportion. So if you do yours a little different but still get the right answer, it's probably okay. So, but for me, since in the problem they have miles and minutes, I'm going to put miles on top, minutes on the bottom. And remember, the proportion, that's just 2 ratios that are equal to each other. So my first ratio is going to be what we already know, 3 miles in 45 minutes. Okay. And then over here, you want to know how long it will take to do 5 miles. So since they say 5 miles, should that go on the top or the bottom? And this is why it's important to have this written out, because I know it, well, miles is on top, it goes here. Okay. If we can identify its proportion, the only thing after that that might be confusing is, well, does it go on the top or bottom? And this will help you, just writing it out. Alright, and since I don't know, looks like we're trying to find out how many minutes it will take, so that makes sense. The minutes is empty, that's what we don't know. And again, I'm going to use T. Usually, anytime we're trying to find a time, we use T. So T. And now we can solve it. Several ways of solving these. One way is to cross multiply. Okay. but we could multiply both sides and divide both sides as well. So I'm going to do some cross multiplying. So 45 times 5 equals 3 times t. 3t. Now it might be tempting to multiply these together, like 45 times 5, what is that, and then divide by 3. But it actually would be a little bit easier if we didn't. Here's why. So we can just divide both sides by 3, and if we can unravel that 45 is 15 times 3, all we need to do is just cancel. Okay, so I took out 45 and put 15 times 3 because 15 times 3 is 45. Okay. Now that's replaced by 15 times 3, and now 3 here and 3 here cancel out. It makes it a little bit easier if you don't have a calculator, instead of multiplying it all together. But of course you'll get the same answer either way. So our final answer will be, let's see here, 15 times 5 is 75. Is t. Alright. And we probably should put the units here. What was 75 what? Okay, that's 75 minutes. And Mrs. Bangle took 75 minutes to walk 5 miles. If she's walking, if she can do 3 miles in 45 minutes. Good. How many feet will she travel in 1 hour? Okay. So we need to break this up into 2 parts. Okay. Okay. First, we need to know how many miles she can do in an hour. So what is the miles per hour? Right? Then we can convert it to feet per hour. We've got to do one thing at a time here. Okay. So we know that she does 3 miles in 45 minutes. That was given from the beginning. So we got 3 miles over 45 minutes. Okay. We want to know miles per hour. How long would it take that for a whole hour? And this is only 3 hours and 45 minutes, so she can do a little bit more. Okay. A couple ways of doing this. But we're going to go this route. So we want to know the distance for 60 minutes. That's an hour. That'll give us how long she can go in an hour. So we can solve this. So we have 3 times 60 equals 45 times d. Okay. And we can multiply this out. This is 180. And divide both sides by 45. And we'll get 4 miles. She can do 3 miles in 45 minutes. She can do 4 miles in 60 minutes. Another way is to find out the unit rate. If we took our scale here, 3 miles in 45 minutes, and reduced it, you can see we can do 1 mile in 15 minutes just by dividing top and bottom by 3, and then multiply that by 4, and you'll see get the same answer. Alright, so now we know we can do 4 miles in 60 minutes. So if we know 1 mile, so right now we know we can do 4 miles, 60 minutes. Or actually, we'll just say 1 hour. 4 miles per hour. 60 minutes is 1 hour. Convert that to feet. Alright, so let's see here. If I want to convert this to feet, I need to cancel out my miles on top because I want to have feet, not miles for my distance. So I know miles should be on the bottom, feet on top. So 1 mile is 5,280. There you go. Miles cancel out. Now I know I can do 4 times 5,280. We get 21,120 feet. And that's in 1 hour per hour. So break it up into smaller parts when needed. If you can't look at it and just say, well, I don't know what to do, we can try something more simple and do smaller steps. Alright, good. Let's keep going. Alright, so David can ride his bike in 5 miles in 20 minutes. Continues this rate. How many minutes will it take him to do 9 miles? Okay, now this is basically the same setup as number 12. You can see instead of running, it's riding a bike. Instead of 3 miles in 45 minutes, it's 5 miles in 20 minutes. So the steps are very similar for number 12 and number 13. Okay. Now if you want to try it a slightly different way, we can do that as well. So let's get started here. So we have 5 miles in 20 minutes. Alright, so we can do 5 miles in 20 minutes. Alright. And continuous rate, how many minutes will it take it to bike 10 miles? Once again, we're trying to find out how many minutes. That's T. And then we'll go 9 miles. Okay. So cross multiply. We have 20 times 9 equals 5 times T. Now again, you might be tempted to multiply these together. It might just be easier if they're compatible numbers here. Just divide. So 5's cancel out. 5 doesn't go into 9, but 5 goes into 20 4 times. So 4 times 9 is 36. So it looks like 36 minutes. David can go 9 miles. So 36 minutes. Alright, just like before, how many feet can we travel in 1 hour? Okay. So let's take our initial rate here, 5 miles in 20 minutes. Okay. How long will it take us to, or how far can we go, distance, in 60 minutes? That's an hour. And let's go through, solve this. I'll let you do the work on this one. I can see that 20 times 3 is 60. So 5 times 3 is going to be 15. 15 is D, and that'd be 15 miles, right? 15 miles. And then once again, we can convert that. I can go 15 miles in 1 hour, 15 miles per hour, right? And you can convert that to feet and saying 1 mile is 5,280 feet. And those can cancel out. So we'll have, let's see, 15 times 5,280. Is 79,200. two problems very similar, number 12 and 13. All right, let's take a turn. We're going to do a different type of problem now. You can see the next two are very similar, and this is probably one of the most useful problems you guys will come across, because you might need to know this and how when you need to get on a certain test in order to make sure you get a B minus in this case, or maybe it's an A minus, you're trying to get a 91%, you can actually calculate what it is you need to get on the next test. All right. So average, we have to remember average. What does that mean? So that's when you add up all the scores and divide by that number of scores. That gives us the average. So if we want to find what's the average of 10 and 12, we would do 10 plus 12 and divide by 2 since we added two numbers. So same thing here, we want to add them all up. So let's see here. Last 10 test scores in Algebra 1 are as follows: 90%, 69%, 81%. Okay, what would James have to score on his next test, next Algebra 1 test, to have an average of 81? So we're talking about 4 tests. There's 4 tests are involved in this problem. There's the 3 that we've already taken and the one that's coming up. So when we have to think about, well, what are we going to be dividing by? We have 4 tests total. Okay? And we know that the average of these 4 tests come out to 81%. Okay? So what are the test scores? What are the 4 test scores? Well, they're 90, 69, 81, and the one we haven't taken yet, that's the unknown. Okay, so I'm going to call that, let's see here, call it T for test. Okay. And now we can go ahead and solve this. Okay, let's add up, simplify the top a little bit, so 90 plus 69 plus 81. And you can go and do that on your own. You should get a 240. Plus one more test. Divided by 4 is 81. Alright. Okay. Now, we have 2 things here. And if I was going to plug a number in here, T, to simplify this, I'd have to do 240 plus that number and then divide whatever that was by 4. So I'm going to do that in reverse to solve it. I'm going to multiply by 4 on both sides and then subtract. Okay, so 81 times 4, and you might want to think of, well, 4 times 80, that might be big for you, but 4 times 8, that's 32. 4 times 80 is 320, 320, plus 4 more, 324. And let's see, so we get 300 plus T divided by 5 is 76. Multiply both sides by the 5. So 300 plus T, 76 times 5 will give us 300. Let's see, 380. Yeah, so 5 times 70 is 3,500. 5 times 6 is 30. No, 350 now, plus 30. So yeah, 380. If you're wondering what I'm doing in my head, I can't really do 76 times 5 easily in my head, so I'm doing 5 times 70 plus 6. See, this is easier to do in my head. That's 350, and that's 30. That's how I got 380 without using the calculator. I'm just using the distributive property. Alright, so we have minus 300 on both sides, and you can see our last test needs to be a B minus. It needs to be an 80%. Okay, let's move along. Almost through. Okay, let's do the proportion problems. Tend to like these. Okay. Alright, again, lots of ways of solving these. Diagram shows a tree and a wall, okay, and there's shadows. Use the ratio to find the height of the tree. So we have, like we did earlier, we have the height of the tree and the shadow. You want to write this down so you know where the numbers go. So the heights are going to go on top, shadows on the bottom. And this is proportion, so we have two ratios equal to each other. The height's on top. Okay, the height of the tree, we don't know. That's h. And its shadow is 24. The height of the wall says it's 4. And its shadow is 6. Alright, we can go ahead and solve this. A couple ways of doing it. Again, you can think of it like the opposite of reducing a fraction, since we know 6 times 4 is 24. So we multiply top and bottom by 4. Or we can cross multiply. Either way will do the same thing. I want to cross multiply. 6 times h is 24 times 4. And this diagonal. And again, I don't automatically multiply those together, because then I'm going to end up dividing, and I can see that 6 goes into 24. So 6 goes into 24 4 times. 4 times 4 is 16. 6 divided by 6 is 1, so we have 16. So the height is 16. 16 what? Right. So look at the units, feet, feet, feet. So we know that 16 feet. And what is the height of 16 feet? Okay, the height of the tree. So we might want to write something out and say the height of the tree is 16 feet. Gotta write it out. You don't want to just say 16, because then the question will be 16 what? You don't want to say 16 feet, because then the question will be, well, what's 16 feet? So if we actually write the sentence out, it actually clears up anything that we might be confused about. 16 feet is the height of the tree. Alright, and we have a few more problems that are very similar. Okay, let's do the same setup. Let's do height on top. And let's do shadow on the bottom. And we're assuming, yeah, there's a sun right here, and it's making a shadow. Okay, so first let's do the height of the tree. We don't know what it is. That's what we're trying to find, so we call that h. The shadow of the tree, so from here all the way to here, that's 24 feet. Okay. And notice how this line tells me that's the whole shadow of the tree. So we do not have to worry about the 8 feet, the shadow of the person yet. Okay, the height of the person is 5 feet. And the shadow of the person is 8 feet. Okay. So we can see, well, 8 and 24 are compatible, so 8 times 3 is 24, so 15 times 3 will be 15, so we can solve it that way, or cross multiply. 8h equals 24 times 5, and when you divide both sides by 8, 8 goes into 24 3 times. 3 times 5 is 15. So we get our answer. Either way, 15 feet. And that's the height of the tree. So pretty good sized tree. Okay, convert number 18. Let's switch gears. Convert 11 yards to inches. And it says 1 yard is 36 inches. Okay. So a little dimensional analysis, we call this. Now the trick was we had to multiply by a ratio. Right? And when we multiplied, we had to make sure units canceled out. Now starting off, the units are always on the top. So I want to answers in inches, which means I want to cancel out the yards. So my yards would be on the bottom, inches on the top. And then I can see, the units will cancel out. My only unit remaining is inches, and that's what I'm trying to get for my answer is inches. So that works out. Let's put in the numbers. We know that 1 yard is 36 inches according to the conversion right there. So we just really need to do 11 times 36 divided by 1. Okay, so 11 times 36 is 396. And then the only unit left over is our unit of our answer, inches. Alright, let's finish this up. Okay, more ratio problems. This time instead of hiking or biking, this is going to be some currency exchange. Alright, so the euro is used from 17 European countries, such as France, Greece, Italy. Okay, exchange rate is $4 to 3 euros. So every $4 here in America will only get you 3 euros. Okay, and the symbol for euros right here, it looks like this. Looks like this. Yeah. So I'll use that just to teach us something a little extra. Okay. And we want to know what we get with 27 euros. So again, I got my dollars on top, euros on the bottom. Just like the height is on top, shadows on bottom, miles on top, minutes on the bottom. We always keep them consistent across. Okay, so we want to know how many dollars. I'll put D for dollars. Okay. So let's go ahead and solve this in a similar fashion as the others. We'll do cross multiplying. 3D, 4 times 27. Divide both sides by 3. And 3 goes into 27 evenly, 9 times. 3 divided by 3 is 1, so dollar amount will be 4 times 9, which is $36. $36. You'll get for 27 euros. If you get $4, $4 will get you 3 euros, then $36 will get you 27 euros. Okay. Alright. Some more proportions. Let's see here. Now Allison's going on a road trip. She can travel 480 miles on 10 gallons. Okay, so let's do our miles on top and gallons on the bottom consistently as we go along. Okay. And we want to see, well, if we can get 480 miles on 10 gallons, which is really good mileage. That must be a hybrid car. 480 miles, 10 gallons. Okay. How many gallons will it take to get 1,200 miles? So I know, again, miles go on top, so 1,200. All right, and we want to know G, how many gallons. Okay. So let's go ahead and break this down. Let's see here. Some larger numbers, so 480. You might do some good actually to reduce this, and that's okay. So we could potentially reduce these to help us out. So we divide top and bottom by 10. That's one way of going. We'll just stick to the usual method since that's what we've been doing so far. There are other ways of solving. And 1,200 times 10. Anytime multiplied by 10, another 0. Okay, divide by 480, both sides. Okay. Start just by crossing off a factor of 10 right away. do reduce that in many different ways, however you can. Okay. But it will come out to about 25. And 25 what? Remember, this is 25 gallons. So we can go 480 miles in 10 gallons. We can go 1,200 miles in 25 gallons, which is really good. It costs you about $80 right now for 25 gallons to go 1,200 miles. Okay. So if the cost is about $4 a gallon, how long we spend to go on the whole road trip? And we just found our whole road trip is 25 gallons. Okay, so we got 25 gallons. Okay. And we know that it is $4 for every gallon, 1 gallon. So 4 times 25, about 100. Okay, so yeah, the gas is $4, but it's $100. Okay. Alright, that concludes our review. Now, here's the thing. You got to do the review several times. Okay? Okay, so for success, success equals success equals studying. Gotta study. Okay? Which means, okay, do review several times. Okay, print another one off a school loop if you can, get another one from your teacher, and do it again and again until you can do it all by yourself. So this is the next point. Okay. Must do by yourself. Okay. Yourself. Eventually. Okay, now it's okay to start off with working with somebody. That's fine, but eventually you do need to be able to do it by yourself. That's when you take the quiz. It's by yourself. Nobody can help you. Can't ask any questions to give you a hint. So do watch the video several times, do a review several times, but the way you know you're done studying is that you can take the whole review by yourself without stopping and get 100%. You can do that and you'll do very good on the quiz. And that's a good indicator to go by on how do you know if you're done studying. Now, if I just took all the reviews away from you, gave you a blank one, and told you to do it, could you do it by yourself with no help and get 100%? Okay? Even though they're the same questions, just redoing it over and over will make you familiar with it and more comfortable. And of course, you have to show all the work. Okay? If you memorize all the steps but don't show the work, you know that none of the teachers here at Upland High will give you credit. Just because you have the answer without an equation, you will get no credit. Show work for everything. Alright, good luck. Thanks for watching.